So here's a little bit of a review of something that we did this week. Of course, we had an abbreviated week. We really spent the first day going over the syllabus, so there was really only one lecture meeting. We took a look at the periodic table and figured out how to determine atomic number, atomic mass, etc. And then I left you on that last day of class last week with some exercises to try out of the lecture outline book, and those are also posted on Blackboard right now, blank copies. I will post answers later today, but I want to give everybody a chance to try them on their own. But I thought I'd do one with you. I know we did beryllium together in class, but I'd like to try one more because I have one extra thing I want to add. So just for the heck of it, let's pick nitrogen. That's nitrogen. If you go to the periodic table, you'll see that nitrogen has an atomic mass of 14 AMU, and it has an atomic number of 7. So you might write it out that way if you would like. And so if it has an atomic number of 7, then it's got to have 7 protons. If it has an atomic mass of 14 AMU and 7 protons, then it must also have 7 neutrons. And because it's an atom and must carry an overall 0 charge, it must be neutral. If it's got 7 protons, it must also have 7 electrons. So you're going to need 7 of each of the 3 parts to make a nitrogen atom. So let's try to draw this. Let's do the Bohr model, and then we can do the Lewis structure. The nucleus of this atom, as we said before, will have 7 protons and 7 neutrons. There you go. And there's going to be 7 electrons. So let's draw some electron shells. I'll use red to draw the shell. So we're going to have 2 electrons in the first shell, because that's all that can fit. You have 7 total, which means you have 5 more that need a home. So the second shell is going to house those 5. Remember that a second shell can hold up to 8 electrons. But watch this. I didn't get a chance to talk about this last week, so I wanted to include it in this video. I need 5 electrons in this shell, but I'm not just going to go 1, 2, 3, 4, 5 and put 5 dots next to each other. Instead, I'm going to do this. Imagine that there are 8 slots on this circle, because you can hold up to 8 electrons. So let's say it's 2 here, 2 here, 2 here, and 2 here, instead of just any old place. I'm going to fill in some 5 of those 8 slots, but I'm also not going to go 1, 2, 3, 4, 5, empty, empty, empty. Instead, watch how I do this. I got 5 electrons to house. I'm going to put 2 together, and then I'm going to put 1 by itself here, 1 by itself there, 1 by itself there. So when I'm done, this is my final Bohr model of a nitrogen atom. When I'm done, that outermost shell has 2 electrons paired with each other and then 3 each off by themselves. That makes a difference. Something you'll see in week 2 is that not only the number of electrons in that outermost shell, but also the arrangement makes a big difference. And if you get into the habit of placing them the way that I just did, it will save you a lot of trouble. So let me review what I just did. Again, imagine there are 1, 2, 3, 4, 5, 6, 7, 8 slots where an electron could go. I'll just go clockwise. It doesn't have to be clockwise. I'm going to need 5 electrons here. I pair the first 2, and then I go single, single, single. Always pair the first 2, and then put the others out singly. If this atom had 6 electrons in its outermost shell, it doesn't. But if it did, then I would have to start putting them together. I'd have to put a 6th one here, a 7th one there, an 8th one there. But, so again, second shell, pair the first 2, and then single, 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 and then if you have to, double them up. Okay? It's not apparent why right now, but that will save you a lot of aggravation going forward when we start to look at things in week 2. It'll be very apparent why it's important to get into the habit of placing electrons in this way. So keep that in mind as you complete the practice problems on pages 6 through 14 of the lecture outline book. As I said, I will post completed versions of those. I have to get to campus today and make nice clean scans of my answer key, and I will post that sometime tonight. This is Sunday, August 28th right now. I'll post those sometime tonight, and you can take a look at those before we meet in class this week. One last thing on this to wrap this up. If you wanted to draw the Lewis structure of nitrogen, remember the Lewis structure is sometimes used. It's useful to have knowledge of this. You just draw the symbol, and then you just draw the electrons in the outermost shell. You don't draw other electrons. You don't draw what's in the nucleus. You just say, there's nitrogen, the symbol, and I'm going to go 1, 2, 3, 4, 5. So this is the Bohr model. This is the Lewis structure. And there's application for each. As we go through the rest of the semester, particularly the next couple weeks, you'll see why it's handy to do this, and other times it's handy to do that. So that was a little wrap-up of a lot of the stuff that we did on the second day of class in the first week. As always, if you have questions, shoot me an email or stop by the office hours this week and we'll talk about it. But we'll pick up making sure everybody can do this, and then we will move ahead into things like ions, isotopes, why this is important, and that's going to lead to a discussion of chemical bonding in week 2. How do you take atoms and attach them to each other so that you can make molecules? So that's where we stand. That's week 1 in review.